we're going to do another two simplifying radical expression problems. So our first one here, we've got the square root of a fraction times the square root of another fraction. And I know that when I multiply two radicals together, I can write them underneath one big radical and then write the inside of each multiplied together. And then if I just focus on the inside there, I know I can split my 6 into 2 primes, 2 times 3. And I want to do that because it'll make it easier for me to simplify if I've gotten things broken down to primes. So really I have the square root of a 2 times a 2 times a 3 for the numerator of my fraction. And I've got a 5 times a 5 on the bottom. And again, I'm not multiplying things together, I'm not combining them, I'm just writing them next to each other because I'm hoping that I have some pairs that I can pull out of the radical. And looking at what I've got here, I can see that I do have some pairs. I've got 2 2's and 2 5's. So if I write my big radical, there's a property that says I can write 2 radicals, one radical for the numerator and one radical for the denominator. And so I'm going to put 2, 2, and 3, and 5, and 5, like that. And then I can focus on the top and then focus on the bottom. So I'm going to pull out a 2 because of my pairs inside. And my 3 doesn't have a pair, so he's stuck inside. So I pulled the 2 out and I've got a 3 left. And then the bottom got a pair and it actually doesn't have anything left inside. So the square root of 5 times 5 just is 5, and I don't have a radical on the bottom, which is nice because I can be finished. If I had a radical on the bottom, I'd have to rationalize the denominator, and that would be more work. So for right now, for this type of problem, we're good. And let's go to the, well, I'll box it. So that would be my simplified. And then I'm going to go to this problem. Again, we have two fractions under radicals getting multiplied. And I'm going to write one big radical with my insides multiplied to each other. And this time, I've actually got a 5 in the numerator and a 5 in the denominator, and so I know that just becomes 1, and I'm left with 2 over 7 inside. And I can split that into a radical on top and a radical on bottom. And when I do that, I see that I have to rationalize the denominator because I have a radical in the denominator. And I'm not finished, I'm not most simplified. So then I have to think, well, what can I multiply the square root of 7 by to get rid of that radical? And I know that if I take something in a radical and multiply by itself, like if I had the square root of 2, and I multiplied that by the square root of 2, I'd get the square root of 4, or 2 times 2, see that it comes out to be 2, and I don't have a radical anymore. And so I want to do that with the square root of 7. Well, so I'm going to times by the square root of 7 to get rid of the radical in the denominator. But if I multiply my expression by the square root of 7, I'm going to change it. Unless I multiply it by the square root of 7 over itself, because remember, any value over itself, 2 over 2, is just 1, for example. So the square root of 7 over the square root of 7, that's really just 1. So I'm not changing the problem, because if I take a number, say 4, and I times it by 1, well, I get 4 back. So it's okay for me to times by the square root of 7 over the square root of 7, because I'm just timesing by 1, I'm not changing the problem. So when I do that, I just think about timesing top to top, numerator to numerator, and denominator to denominator. I'm going to erase this so I have room. So I get the square root of a 2 times 7, putting the insides under one big square root, and square root of 7 times square root of 7 again gives me 7, which is the whole reason I picked the square root of 7. So now my denominator doesn't have a radical. I just need to clean up my numerator. 2 and 7, there aren't any pairs, so I'm stuck with both of those inside, and then I can multiply them together and write them as 14 to make it clean. And that would be my final answer. Square root of 14 over 7. I don't have a radical in the bottom, and I don't have any pairs that I can pull out from inside the radical on top to make it simpler, so that's simplified.